everybody. This video covers the AMDM Unit 2 Quiz Review Number 1. Question 1. What do you think the two categories would be for this scenario? It says, for the away RHS football game, 180 students rode the bus out of 400 total students that attended. 115 students were freshmen. There are 25 freshmen that did not ride the bus. All right, looking at the highlighted information, we see that there are 180 students who rode the bus and that there's 115 students who were freshmen. So our two categories should be students who rode the bus and freshmen. All right, number 2, what do you think the two categories would be for this scenario? During Sea Lunch at RHS on Thursday, 168 students bought pizza out of 350 total students that were at Sea Lunch. 123 students were sophomores. There were 32 sophomores that did not buy pizza. All right, looking at the highlighted information, we see that there are students who bought pizza and there are students who are sophomores. So our two categories should be students who bought pizza and sophomores. All right, question 3. A marketing class polled 150 people at Lenox Mall to determine how many watch The Real Housewives of Atlanta and how many read books. They found that 106 read only and 31 read and watch The Real Housewives of Atlanta, and 10 do not read or watch the show. Fill in the Venn diagram below. Well, it should be obvious that the two categories are those who watch The Real Housewives and those who read. Now, the first number that we can place here is the 106. They found that 106 read only. So 106 would be inside the read circle, but not inside the Real Housewives circle. We then know that there were 31 who read and watch The Real Housewives. So 31 would go in the space where the two circles overlap. We can then place the 10 here because it says 10 do not read or watch the show. So that means 10 will be outside of the two circles. And finally, we need to know what number goes in this space. We can take the total number of people, which is 150, and subtract these three numbers from 150. When we do that, we end up with 3. That's 150, subtract 106, subtract 31, and subtract 10. And you get 3. So 3 goes in this space. So the 3 represents those who watch Real Housewives only. 31 is those who watch Real Housewives and read. And 106 is those who read only. And 10 is those who do not watch or read. All right, question B. What is the probability that a person reads and watches the show? Well, we can see right in the middle that there are 31 who both read and watch. And therefore, that's going to be 31 out of the total of 150. And that is the answer. Question C. Find the probability of those who read or watch the show. Well, those who read or watch the show would be the sum of 3 plus 31 plus 106, and all of that out of the total of 150. So 3 plus 31 plus 106 out of 150 is 140 out of 150, and that reduces to 14 out of 15. And question D. Find the probability that a person reads given that they watch the show. Now, because it says given that they watch the show, that means that the bottom number is not going to be out of 150, but it's only going to be out of those who watch the show. So to answer the question, we figure out how many just watch the show, and then on the top would be those who read and watch the show. Well, those who watch the show are 31 plus 3, which is 34. And out of those 34, there are 31 who both read and watch. So the answer is 31 out of 34. Okay, number 4. For a prom fundraiser, the junior class constructed a maze out of large boxes and sold tickets to the maze. As an incentive, Donated prizes were placed at each exit of the maze as shown below. Students paid $10 to enter the maze. Question A. Construct an area model that represents the probability of winning each prize. Assume that participants can only move forward through the maze. The first thing we need to do is to number all of these paths, all of these sections. We'll start at the very beginning, and we have 3 choices at the beginning. We can go path 1, path 2, or path 3. Now let's travel along path 1. Path 1 splits here into paths 4 and 5. Now let's continue along path 4. Path 4 would split into paths 7 and 8. Path 6 and 7. And 6 takes you to the end, and 7 takes you to the end. And also back here at path 5 would also take you to the end. Now let's travel along path 2. If you're traveling along path 2, when you get here, you would split into paths 8 going up and path 9 that would keep straight. Path 8 merges with path 5, taking you to the end. If you travel on path 9, you would get to this junction, and path 9 would split into 10 and 11. Let's go back to path 3 now. If you're traveling along path 3, when you get here, you would split into paths 12 and 13, and both of those take you to the end. All right, now we'll use all of this information to develop our area model. The first thing you want to do is to split this up into 3 paths. Those represent the 3 original paths, 1, 2, and 3. Now we're just going to go step by step, traveling along path 1 and splitting at every junction. So if you're on path 1, remember path 1 split into 4 and 5. So that would be represented down here by erasing 1, cutting it in half, and splitting it into 4 or 5. And there you have what used to be path 1 is now split into 4 and 5. Continue on path 4. Path 4 will split into 6 and 7. So what used to be path 4 over here is now split in half into 6 and 7. Now since path 5 takes you all the way to the end, we're not going to split 5 at all. We're just going to leave it as it is. Now let's go back to path 2. Path 2 splits here into both 8 and 9. So we will need to split this 2 here into 8 and 9. So we erased what used to be a 2, and now it's 8 and 9. Path 8 takes you all the way to the end, so we'll leave 8 alone. But path 9 will split into 10 and 11. So what used to be 9 here was cut in half and then becomes 10 and 11. Now both 10 and 11 take you all the way to the end, so 10 and 11 now are left alone. Let's go back to path 3. Path 3 splits here into 12 and 13. So what used to be path 3 here has now been cut in half and split into 12 and 13. Both 12 and 13 take you to the end, and that completes all of the splits. The next step is to split this space up into boxes of all the same size. So let's split up box 8, cut it in half, and then we have 2 smaller 8s there. We'll do the same thing with box 5. Let's split it in half, and then you have 2 smaller boxes of 5. Same thing with box 12. We'll split it in half, and we have 2 smaller boxes of 12. Then box 13, same thing. Let's split box 13 in half, and then we have 2 smaller 13s. And now we have an area that's divided into boxes that all have the same size. As a matter of fact, there's 4, 8, 12. There are 12 boxes all with the same size. That's going to make it easier for us to find probability. Now let's find the probability of getting each one of these prizes. First, let's do the laptops. Only path 6 leads to laptops. Let's look down here in our area, and we have only 1 box out of 12 leading to laptops. So the probability of getting a laptop is 1 out of 12. Let's find the probability of getting a gift card to Starbucks. Path 7 leads to the gift card, path 5 leads there, path 8 leads there, and path 10. So that's 7, 5, 8, and 10. Let's count how many of those we see in the area. We have 1 7, we have 2 5s, we have 2 8s, and we have a 10. That's 1, 2, 3, 4, 5, 6. That's 6 out of 12. So the probability of getting a gift card to Starbucks is 6 out of 12. Now let's find the probability of getting a free movie pass. There are 2 paths that lead here. That's path 11 and path 12. So we need to count how many 11s and 12s are in this area down here. There's 1 11 and there's 2 12s. That's a total of 3 boxes out of 12. So the probability of getting a free movie pass is 3 out of 12. Finally, what is the probability of getting a gift certificate to the mall? Well, only one path leads there, and that's path 13. We need to count how many 13s we see in this area. There are 2 boxes here, so that's 2 out of 12 is the probability of getting the gift certificate. And now we're ready to answer part B. It says, which item has the least probability of being won? Well, the least probability is 1 out of 12, which is the laptops. So we simply say that the laptops have the least probability, which is 1 out of 12. Okay, and there's our statement there. All right, let's answer question C. Which item has the greatest probability of being won? Well, the greatest probability is the 6 out of 12, which is the gift cards to Starbucks. So we would simply say the gift cards have the greatest probability at 6 out of 12. That would be our statement. And now part D. It says there are only 3 laptops to give away. After the 3rd laptop is found, the maze manager closes the last path split that leads to the laptop area. How will this affect the probability of receiving the other prizes? Support your answer. All right, the way that was worded can be a little confusing, but I'm going to interpret it like this. When all of these laptops have been taken, then there's no sense in having this path open, path 6 open. So I'm thinking that we are going to close the path to 6. So we just create a barrier here so that you can no longer get to 6. So what that means is the 1/12, the 1 out of 12 that would be coming here to the laptops would now be diverted down through path 7 and into the gift card space. So then you would end up adding 1/12 to the 6/12 that's already there. So the new probability of the gift cards would become 6 plus 1, or 7 out of 12. And so our final statement could say that closing the path to the laptops will increase the probability of the gift cards from 6/12 to 7/12. The other probabilities are unchanged. All right, here's problem 5. Subway brings a stand to RHS for a fundraiser month. For $4, you can build a sandwich by choosing one item from each category below. The Subway representative has calculated from company statistics the probability associated with each choice, as shown in parentheses. So what we see here in the table is that the likelihood of choosing bread is 40% honey oat and 60% white. For the meats, the probability of choosing ham is 55% and turkey 45%. And for the spread, the probability of choosing mayo is 60%, mustard 10%, and ranch 30%. All right, question A says draw a tree diagram to represent the sandwich choices. First, we draw 2 branches, one representing the honey oat bread and the other representing white bread. We put the percentages there. Honey oat is 40% and the white is 60%. Next, you will draw two branches from the honey oat to represent your choice of meats. That's ham at 55% and turkey at 45%. But you also have to write it here from the white bread as well. So if you choose white bread, you can choose ham and turkey. Ham at 55%, turkey at 45%. Now we go to the third level, and the third level is when we begin to choose the spread. So here we have, if you choose ham, you could choose one of these three spreads: mayo at 60%, mustard at 10%, and ranch at 30%. Same thing if you choose turkey, you would have these three choices of spreads. Same for ham, you would have three choices of spreads. And same for turkey, you'd have three choices of the spreads. So this is a complete tree diagram showing your choices of bread, meat, and spread. All right, question B. How many sandwich combinations are there? Show your work or explain. All right, so there's actually two ways to do this. The two ways to answer this would be to, number one, we could count. You're going to count the last level here. How many options do we have at the last level? We have mayo, mustard, ranch, mayo, mustard, ranch, mayo, mustard, ranch, mayo, mustard, ranch. That's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you just simply count the last level and you have 12. The second way of doing it is by multiplying the number of options. There are 2 options for the bread, there's 2 options for the meat, and there's 3 options for the spread. So that's 2 times 2 times 3, and you get 12. All right, question C says find the probability of choosing honey oat with ham and with mayo. The way you'll do that is you'll simply multiply the 3 probabilities together. The probability of choosing honey oat bread is 0.4, the probability of choosing ham is 0.55, and the probability of choosing mayo is 0.6. You would just multiply those 3 numbers together, and you end up with 0.132 as a decimal, or as a percent, moving the decimal point to the right 2 places would be 13.2%. All right, letter D, find the probability of choosing ham. Well, if you look up here, the probability of choosing ham is just 55%, or 0.55. So you can write it as a decimal, 0.55, or 55%, and that's it. All right, letter E says find the probability of not choosing mayo. Well, the probability of not choosing mayo is 1 take away the probability of choosing mayo. Well, that's equal to 1 minus the probability of choosing mayo up here was 0.6. So that's 1 minus 0.6, and that is equal to 0.4. So that's your answer. And I should mention that you could also change the 0.4 to a percent, so it'd be either 0.4 or 40%. All right, letter F says find the probability of choosing mayo or mustard. Well, the way that works is you simply add the probability of mayo plus the probability of mustard. Let's look back up here at the top, and the probability of mayo is 0.6 and the probability of mustard is 0.1. You just simply add those 2 together. So it's going to be 0.6 plus 0.1, and of course that is 0.7, or as a percent, 70%. All right, question number 6 is asking us to draw an area model for the maze below. We'll start by looking at the first junction where we split off into 3 paths. We're going to number those paths 1, 2, and 3. Next, we'll follow path 1 up to this junction, and at this junction it splits off into 2 parts, and those would be paths 4 and 5. Path 4 leads us to gold, and path 5 leads us to the bronze. All right, let's go back to path 2. If you follow path 2, you get to this junction where you have 3 options. These would be paths 6, 7, and 8. Those are the 3 splits, path 6, 7, and 8. All right, path 6 leads you to silver, path 7 leads you to bronze, and path 8 leads you to gold. Now let's go back to path 3. If you follow path 3, there are no splits there, so path 3 takes you all the way to silver. All right, now we begin to draw the area model. We start at the very beginning with path 1, 2, and 3. So let's draw those 3 paths. 1, 2. All right, so path 1, 2, and 3 has to be paths or rectangles of equal size. So here is path 1. Here's path 2. And of course, path 3 is at the bottom. All right, paths 1, 2, and 3. Next, we will follow path 1 until it splits. Path 1 splits into paths 4 and 5. So what we'll do is we'll come down here to path 1, we'll erase the 1, cut it in half, and split it into paths 4 and 5. All right, so path 1, I erased path 1, I cut it in half, and now we're calling it 4 and 5. All right, and then that's done there. Now let's go to path 2. Follow path 2 until it splits. Now this splits into 3 paths, and those paths are 6, 7, and 8. So what we'll need to do is erase the 2 and split it into 3 equal paths, or 3 equal parts. So let's erase path 2, and now we're going to split this area into 3 equal parts. All right, so here are my 3 equal parts that path 3 split into, and that splits into paths 6, 7, and 8. Now the way you do this is if you count the number of dots all the way across, you'll find that there's 24 dots all the way across. You want to split that 3 ways, so 24 divided by 3 gives you 8. So that means boxes 6, 7, and 8 are all 8 dots long. And now for path 3, we can see that path 3 does not split. It takes you all the way to the end. Therefore, we're not going to split up path 3. All right, the next thing we want to do is we want to divide all of this space into smaller boxes so that all of the boxes that we see are the exact same size. So what you do is wherever you see a line, you just want to carry that all the way through. For instance, this line right here, I'm just going to carry that all the way down to the bottom. So I'll carry this line down to the bottom, and as I'm doing that, then this box that was a 7 splits into 2 smaller boxes, each of 7. Okay, and then I'll erase the original 7. Now let's extend that line all the way down here, and this box, this big box 3, will then split in half, and then we'll have a 3 here and a 3 there on either side, and then erase the 3 that was in the middle. Okay, and now we'll take this segment here and let's extend that straight up. There we go. Extend that straight up, and now that splits into a smaller 5. Let's extend this down, and this is also part of box 3. Okay, now we need to take this box of 8 and make that smaller. So we cut that in half, and now we've got 2 boxes of 8 here. Take this larger box that's a 5, cut it in half, and then now we've got 2 smaller boxes of 5. Let's take this box that's 4, and let's extend this line up, and this will be a box of 4. And then let's cut this in half to make that smaller, And so now we have a 4 here, and we'll also have a 4 here. You take this box that's 6, let's cut that in half, and now we've got 2 smaller boxes of 6. Let's take the 3, and let's see, we'll extend a line down here and extend a line down there, and then we've got 3 smaller boxes, each of 3 as well. And then one more, we've got a big box here. We're going to cut that in half, and then we'll have 2 small boxes of 3 here. Okay, now you can see that the space now is divided into all smaller boxes of the same size. Now the next thing is you want to establish how many of these small boxes you have. So there's 1, 2, 3, 4, 5, 6. There's 6 boxes going across, and then there's 3 levels, and that 6 times 3 makes 18. So there's 18 small boxes here. So any probability that we talk about is always going to be out of 18. All right, let's answer question A. Question A says, what is the probability of getting gold? Well, let's see, what paths lead to gold? Path 4 leads to gold, and path 8 leads to gold. So we're going to count all the boxes that have 4 in it and all the boxes that have 8 in it. So there's 1, 2, 3, 4, and 5. There are 5 boxes that have either a 4 or an 8. So the probability of getting gold is 5 out of 18. Okay, question B. What is the probability of getting silver? What paths lead to silver? Well, path 6 leads to silver, and path 3 leads to silver. So down here we're going to add all of the boxes that have a 6 in it or a 3 in it. So there's a 6, there's another 6, and then we have all 3s down here. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 boxes that have either a 6 or a 3. So the probability of getting silver is 8 out of 18. 8 out of 18. All right, now the last question. What is the probability of not getting bronze? Not getting bronze. Well, the probability of not getting bronze is equal to 1 minus the probability of getting bronze. So let's figure out the probability of getting bronze, and then we'll subtract that from 1. All right, here's bronze. How many paths lead to bronze? Well, path 5 leads to bronze, and path 7 leads to bronze. So that's 5 and 7. Let's count all the boxes with 5s and 7s in it. Here are 2 5s, and here are 2 7s. So that's 1, 2, 3, 4. 4 out of 18. So the probability of not getting bronze is 1 minus 4 out of 18. Now, you change the 1 into a fraction, which is 18 out of 18. Take away 4 out of 18, and that leaves you with 14 out of 18. So your answer is 4 out of 18, which is the probability of not getting bronze. All right, I should mention before we leave that the 8 out of 18 can reduce to 4/9, and 14 out of 18 can also reduce to 7/9. All right, that concludes our quiz review.